Maybe the first thing is just to address why architecture and computer science. I know that you are applied computer science. What would be the relation between those? And hopefully some of the first few projects that I'm going to start showing will start giving you an hint of how we're using computation, or how different ideas of computation started kind of being played out for architecture projects. So I studied in a program called the DRL in London. This was a design research lab, and we learned how to do a bunch of different techniques, how to create architecture out of programming. And I started working also with a firm called BioThing. This is a project that we did within the office. And what I was doing back then was working, maybe you're very familiar with this platform processing, where I learned how to program. And we started doing architecture. In this case, we were printing, called the Turing Pavilion, and we were controlling like a very simple algorithm, a reaction diffusion algorithm that would kind of change over time. The reaction of cells in proximity would actually start kind of transforming over time, but we were using that process to start printing that point cloud over time. So I was very, very intrigued of how architecture could be defined by programming, by constructs that were not just a building, a form, but rather a process. And processing, especially being an object-oriented language, provided a framework for me to start thinking of a series of architectural objects, things that were both material and immaterial within the environment, to think of spaces. In some cases, this object would be like an attractor or repellent, or something that would accelerate the growth of these kind of structures, or it would actually stiffen and strengthen the kind of the materiality when we were printing, right? In this particular project, we were working with an Italian 3D printing machine, which might seem pretty ancient for these days, but it would actually be able to do large-scale 3D printing, right? So it would be printing dust, like glue over dust, and start creating this kind of stone-like formation. So we were speculating that such architecture would be able to be defined at a molecular scale almost. Like the point cloud that we had didn't have necessarily the resolution that we would want to, that we were exploring. How do you define not a boundary representation of a surface, but rather kind of the intensities of the glue and the molecules that would actually allow for the binding. So this is the kind of project that would come up out of it. Like at the end of the day, eventually we needed to kind of wrap into a mesh and a surface these geometries. But that was the objective. We wanted to really kind of directly connect the machine, the code with the machine, right? Like we wanted to connect the generative process of design with the machine. And somehow I just to be completely honest, I was slightly disenchanted with the ability of being able to code a system or a piece of form in architecture and being able to take it into manufacturing. I felt that I was missing an opportunity as a designer to be able to kind of tweak and move the project around in a much more intuitive way, right? The code always felt like I was doing everything in a very kind of predetermined, organized way, but I didn't have the intuition that I would be able to have with a traditional form of modeling. So in my mind, the relation with a medium, a computational medium, started being a bit more flexible and a two-way direction. In a sense, I wanted a medium, a computational medium where I could just move things around, even like in a top-down fashion. I could just be able to shift things around, and then I would get responses from this particular software, right? And in my mind, that looked very much like a game. I played video games in my youth, and then I thought, well, video games are software as well. But in a way, the relation that I was establishing with the software, I wanted to be able to move freely within a kind of a computational environment and get feedback. So I started research working on games and understanding that games perhaps were a different approach to design and architecture. So I'm going to go through a few projects and we'll start showing that transition towards games, some of them more physical, and then later some projects that are more physical. And for me, I really started kind of looking at the notion of parts. Again, I was very close to the idea of object-oriented programming and the modularity and the reusability of objects, both in programming format, but also in the literal format, in the case of the tectonic format of architecture, right? So a modular brick, a modular wall, different components that could actually be combined differently, for me really offers a whole series of possibilities. And in this case, Lego, this image is always important for me because this is how I see the field of architecture and design really operating, right? You have a large field of possibilities, of building blocks that are kind of completely disorganized, disconnected from one another. And then you have a social system that is on top of it. And what the social system is really doing is kind of creating patterns, creating structures, organizing, kind of a process of negative entropy, if you want, of kind of building structures that resonate, have meaning and value. And those structures perhaps resonate within not only one person, but maybe a group of people, a pocket, right? And those structures perhaps are copied by other groups, and they start replicating. So I always try to describe for me what architecture really is, and between these two models, like if you go to Home Center and you see all the building materials for architecture, and then a finished building, and what happens in between, that's obviously what we architects do, and for me that could be understood as just energy and data, right? It's kind of the energy of both conceiving the structures, but also like putting those parts together. The data really defines what parts go with one another. What is the topological diagram of the architecture, right? And this is what I think, like, for me, this kind of literal translation, we as a discipline of design would sit in the middle. And again, this analogy could be taken further also to the digital realm. So I started working on, I had the opportunity to propose a project which wanted to test out some of these ideas in a physical format, right? So this was 2012, it was the London Olympics, and I proposed a project that it would be like a Lego building block, but obviously with a whole series of rules and geometries to allow for a much larger installation. And what we did was to create one unique unit, right? So serially produce a unit that would be able to be combined with itself in multiple permutation, right? So you can see here, this is the kind of the CNC mold for doing injection molding, so that you can actually produce many copies of these pieces very quickly. And this is a piece that we designed. So what you can see here is that there's 3 connections, and the angles between them, if you kind of realize the angle between the tail, if you want to call the tail, and the front, they're kind of very parallel to each other, right? Same thing happens with this other angle over here. So what you end up having is kind of a very kind of open spiral that creates these kind of swirled shapes. But getting there was kind of a bigger deal, like figuring out how to anticipate all the kind of constructions that people would be able to put up with this form was very important for us. So we obviously did some physical prototypes, some like wood installations or prototypes that would allow us to kind of start kind of envisioning, but we definitely needed some form of simulation to anticipate what kind of patterns could we create. So often when I talk about this project, I talk much more about the social nature of the project. In architecture, these projects often are not to be touched, but we wanted people to kind of move pieces around, to remove them and kind of create new patterns and add new logic or new meaning to the project. And as you can see, we definitely did that. We had like thousands and thousands of pieces in those kind of gray boxes that you see in the back. People would be able to take as many as they wanted, even take some of them home to play with them, and they would leave behind, tokens of participation, these kind of structures that for them were meaningful, many times games or in a way, little pavilions in a way that would kind of show what they were kind of engaging with. So this is a video that we produced at the time, and I often don't show this content anymore because I guess that for quite some time I was very obsessed with technology, and somehow that obsession kind of receded to kind of move towards what is the intention and what is the kind of ultimate goal of the research. But I kind of wanted to dig some of these videos out, and this is again working in processing, creating kind of a simulation of an L system, like a branching system that would allow us to kind of shift the angles, the vectors of growth of the cell, and starting to see what should be the anatomy of the cell at the same time when we were simulating how those pieces would be aggregated, right? So this was a very first attempt to start thinking, well, this would grow, and if it has these particular angles, it would look like this, right? That's not to say that people wouldn't break the rules or that the pieces wouldn't bend and flex with the material, but at least it started to give us some initial sense of what were the right kind of angles that would actually work for us. We wanted to make the game relatively difficult so that you couldn't just create a structure to start climbing, but as you kind of hit a taller and taller structure, you would actually be able to, the structure would actually collapse, so you wouldn't have kind of the risk hazard of people creating something that then eventually climb and then fall. This is you're probably familiar with as well, Grasshopper, the plugin for Rhino. So this, like we were developing this project slightly before 2012, so in 2011 we were already thinking, using some of the Python modules, I think at this time, of defining the geometry again and the angles of the geometry through a parametric component, right? So I try to put a lot of emphasis in my work on, especially in the technical sense, of a distinction of what I call parametrics and what is combinatorics, meaning that the discrete patterning of pieces, for me, it's a process of combination, permutation, that it sits for me very differently to the process of parametrics that relies on the moving or stretching, continuously sliding through these parameters, right? And that's something that we can definitely talk about, and I think that you're more interested in. But in this case, they were both, right? The pieces needed kind of a particular pattern structure of how they're related to one another, but also had the parametrics that would allow them to deform and shift so that we could eventually start getting these shapes where we were actually happy with the result, right? And you can see the iterations that we were having over these pieces. The piece wasn't really designed initially as it was, but like it went through a process of iterations that and structural engineering and simulation to reach the final shape. I can share that it was a particularly stressful project because all the responsibility was in one final piece. So when you say go and you create 100,000, like one mold that would create 100,000 pieces, it's not that you can correct it. It's like basically everything goes through the kind of the engineering of that unique unit. But it didn't fail. It actually worked pretty well. It was well received by the City of London, and we were able to show it in many scenes after that. So this is kind of the stage of the app. It was never packaged to be something that someone else could use. It was just meant to create geometries and simulations for us. And we eventually, the content for the competition was developed through this system. So these are some of the renders and the images that we were anticipating before the project was actually manufactured. And I think that some of these images resemble pretty closely to what we actually use. So the pigmentation, obviously, and all that changed slightly, but as you can see, people were able to combine these pieces many times in the patterns that we had anticipated, but many times breaking those rules and taking them further, which I think was some of the most interesting moments. And we definitely wanted to kind of engage with schools and engage. The game became a very kind of educational piece. Like people, like especially kids, would have actually started understanding logic and how patterns work. If you start repeating the same connection, you will actually get a circle, a spiral. Or if you start repeating a different pattern, you would actually get a specific arrangement. I really tried to relate some of the ideas of the project with these ideas of combinatorics and how the intensive existence of parts that could be combined in different ways would allow for creativity and would allow innovation. I think that there's this really great documentary by Wire magazine on the city of Shenzhen, and it suggests precisely this idea that Shenzhen has such a large population of hardware where people can really kind of mix and match, kind of combine pieces in a very kind of without friction, right? To allow for the innovation of individuals. And I think that that's the way in which I conceive of an architectural platform, right? Like the title of this lecture was, how do you start designing architectural platforms? And even then with Bloom, I was thinking, how do you do a platform for architecture and not necessarily a building, right? Not one piece of geometry, but rather kind of a possibility of buildings, right? And that's some of the ideas that I've taken into the digital with my video game projects. So as I talk about parts, you combine parts, you get patterns, and I think that patterns for me have become incredibly important, right? Like the social action in the case of Bloom or in the case of a video game has to do with creating and finding patterns that have more value or meaning than others. So this is, after finishing Bloom, I started doing a studio in UCL, in London. And I was encouraged by the chair at the time to start a new agenda, something that we hadn't seen before. Some of the other students were definitely working with code, and they're working with programming in general, but they saw that I could actually bring something to the table. And my passion for games and transitioning from processing to game engines like Unity was an opportunity to start thinking of a system that was algorithmic, that was actually a code project with a series of constraints and rules, but at the same time would be very flexible to the input of a player, right? So the player would become like the wild card, if you want. The player would always poke the system in multiple directions, and it would be a kind of a big uncertainty to the system. But the system needed to hold. And we started developing these architecture projects, what I call gamescapes. Is that an image or a video? Maybe just. Okay, so these are just two images. I wish I had the videos with me as well. So these were some of the first video game projects that we did that year. And we were looking at things like as simple as Minecraft, right? How do you kind of combine different tiles, allow for rotations? And in this case, this project, what it was trying to do is create a form of conductivity. So the tiles would represent a form of electrical current, and you would be able to kind of pattern the way the energy was kind of collected, transferred through the bricks of the project, and then also stored, right? So you would have some tiles that would operate as batteries, some tiles that would operate just as wires, and some others that would actually harvest the wind, in this case, from these little kind of wings, I guess. In the second project, again, similar to the electricity transferring problem, we were working with water, and how do you collect water, how do you kind of move the water through a system, and how does the building kind of, in this case, this prototypical building starts kind of shifting weight when water resides in different areas, right? So the students were really thinking of how to create farming, or how to deploy and desalinate water systems through the kind of the architecture fabric, right? So these video games were interfaces where students would be able to kind of create a tile, rotate it, manipulate it, and then grow a pavilion-like structure from them, right? Really anticipating what would be the kind of architecture work from a video game perspective, right? The metrics that were offered to the player would always allow or support decision making. So the idea here was not to have one optimum decision and say this is the best configuration that you can actually achieve, but rather give you different criteria so that you could actually always decide which way to go, right? So you put in contrast things like temperature or the optimization of weight and structure, and you basically have a system that needs to kind of navigate a large space of possibilities. And I think that that's where humans, especially human designers, and intuition and experience play an important role in relation to algorithmic systems. So that was the point in which I moved to Los Angeles, and I started this research that I call PolyOptics here at USC, where I teach currently. And polyomino, it's a word that represents these kind of molecules of square tiles, right? You have a multiplicity of these square tiles. These tiles were actually popularized by games like Tetris, and for me, it was a kind of an opportunity to kind of emphasize my interest on discreteness, right? Discreteness understood in the relation that parts establish with one another, right? Like, so autonomous parts, like in the case of the domino, have a particular pattern that they have synergies with one another. They match, or you can actually create system or structure out of them. And that's the way we started thinking of architecture. So these are kind of an architectural brick using a truncated octahedron that, while patterning with some colors, would allow for synergies or connectivity between other tiles to enable kind of a piece of architecture, a chunk, of, let's say an abstract form of architecture that would start using these rule sets, right? What we did then is like inscribe the geometry within that tile. The tile would be the kind of the capsule for carrying that piece of geometry, and we were able to grow these structures that were definitely using space packing geometry, but in a much more sophisticated way, I guess. We were really trying to kind of create geometries that would transition nicely with one another, but they would actually be defined in really finite descriptors. So most of the work that we were doing had to do with patterning and shifting the combination, similar to Bloom. What we were trying is really to find which patterns would allow for let's say, a wall that would kind of mediate the light, or a wall that would actually hold structure, and what are the performances that some of these patterns would actually be able to engage with. And obviously, not everything had to be built physically. I find a great joy and also a great opportunity to do these simulations in gaming engines like VR and keep on learning how to do better content within Unity and things like that. So simulating these things digitally was always a mixture between a kind of a very constrained digital system, but a very kind of open-ended and flexible, intuitive system in the form of a video game, right? So this was a much shorter project. It didn't have the kind of the amount of data that some of the other projects had. What we were trying to do here is really connect the construction of these sculptures, if you want to call them that, into a 3D printing machine, right? So we were being sponsored by Stratasys, the 3D printing company, to really connect what is the gaming culture with the making culture, right? How do you make that transition and allow for a very easy to use software, but at the same time you could actually create very sophisticated design patterns, right? So we did two versions of that project. One of them where you would actually print the large pattern, and we did a couple of sculptures for exhibitions with that. And this version of the project was meant to be printed out of individual pieces. So the pieces would use a magnetic connection. Just by having a large range of colored pieces, you would use those pieces almost as pixels to kind of start kind of shifting and grading coloration, just because in this case the machine as well had the capacity to print in multiple materials. So we really wanted to test what would use kind of a three-dimensional canvas for people to engage with. A very simple geometry that would always be space packing, or create space packing, that in this case would be able to be manipulated by a player and grow this coral-like structure. It's kind of a long video, so I'm going to quickly. So these are some of the 3D prints that we got out of that, where you can see that depending on the sequencing of those parts, for me, like often repetition and particular kind of mathematical like sequences create legible order, and those were the ones that we were kind of maintaining or kind of continuously developing for what would become ultimately the printed pieces. And later, so that's kind of the final image of that version, black and white version. And this is a kind of form of magnetic gameplay that you would be able to do with the physical unit. We printed about like several hundred of these units. Were highly more expensive than the injection molded pieces that we did for Bloom, so we didn't really scale the way we wanted. But at the same time, we really kind of started speculating how 3D printing was a great method not to be able to carry plastic from one place to the world to another, to like in the case of Bloom, but rather kind of how to share files, how to put those files online so people would actually be able to print them in their own 3D printing machines, like glue some magnets on them and allow for local fabrication. So those 3D printed in that case became a vehicle for more of a DIY approach. So yes, these are some of the images. I think this is also a video, but it definitely you kind of see. This was the final version of it, right? That we created as an installation piece for a bunch of different 3D printing exhibitions. That we're really trying to look at the opportunities of 3D printing in different formats. So as I mentioned, 3D printing technology has a great capacity to kind of create geometries almost at a molecular scale with different flexibilities, colorations, and stiffness. But at the same time, it's a technology that allows us to share files and disrupt the kind of the distribution systems, right? Like the way in which we transfer goods around the globe. And I think that that's where it's most disruptive. And I like to, usually in architecture, I like to discuss the idea of the commons. And that's something that is currently on my mind. I've been trying to write a lot about. And maybe it's not the right place to discuss it, but I think that the projects that I'm engaging with right now, especially thinking of architecture platforms, especially with games like Blockhood, and a current project that I'm working on right now, is to think that social production should be obviously owned by whoever produces it. So in the case of this case of a video game, a user that really engages with the creation of content should be owner of its own production. And potentially, if we are able to collaborate and share some of the content with one another, that could actually contribute to commons, like a pool of resources for knowledge, for the learning of techniques, that I think that would greatly accelerate the way we think of architecture just by sharing the patterns that we have created. So Blockhood is a project that started conceiving of some of those ideas in a video game format. I started this project in the city of Hong Kong in 2014, and I was doing this conference with two friends, Sergio Irigoyen and Satoru Sugihara, which I wish he was here. He would be a great addition to the lecture series again. And really looking at Hong Kong as a kind of a three-dimensional voxel structure, right? Like a matrix, a three-dimensional matrix where each part could be thought of independently and it could actually change in program. So Blockhood obviously follows the tradition of city building games like SimCity, and more recently like City Skylines, but obviously being a very small team, meaning me and maybe one student that was working with me at the time. It was a very ambitious project for a small team to accomplish, right? So we decided to really focus on one city block, right? Not to think of the whole city, but rather one city block. And engage with some of these core mechanics, which is ecology, entropy, and coexistence. And I try to explain how those play out. So the idea of ecology is that every tile in the game would have an interdependence with another tile, right? So if a tree would require water, you would need to get that water in order to produce fresh air or oxygen, right? And the moment that all tiles have that constraint, that kind of dependence, you create a mesh or a web of interdependence, right? There's no beginning or end. Like wherever you start creating your own problems as the system will start kind of asking you to provide the answer for those. And it really starts giving you an ecological vision or version of the city, right? Many of those ideas were influenced by the Plant Chicago, which is a urban farming facility that basically works with this principle that there's no such thing as waste, and waste is only what we don't really use. And if something, the waste of one entity becomes the input for another one, then you're actually having kind of a system that is quite efficient. So this is kind of where the project is right now. We do have. Yeah, so that's kind of a trailer. So I'm going to leave it running while we talk a little bit about it. It obviously has kind of a whole presentation that is trying to appeal to this kind of ecological message and all. But it's really trying to make out of a portion of the city a toy, right? One that you can play and tinker with. And one of the key challenges for the project was not to kind of create a very biased perspective of what the player should do, but rather allow the player to explore different areas, right? You could explore the production of oil as an energy source. You could explore the production of food through an industrial food system. And the system shouldn't be able to tell you, hey, no, this is not the ecological way of thinking. It would only give you the data and the consequences of those decisions, right? So if you create an industrial food system, there's perhaps a lot of things that you have to address, right? And just by making those explicit and not allowing you to kind of dispose of, let's say, residues somewhere else in the map, just having to take care of everything, And the game would start to kind of home in a notion of the ecological impact of your decision. Right? So as you can see here, you have a large set of tiles that you can work with, and as you're growing this tower or this kind of vertical neighborhood, each tile would be requesting resources to grow. One of the things that I really wanted to do is not to really make a model for a city, but rather make a kind of a more of a universal model where you could actually play without doing a building at all, right? So you could actually make a forest, and then animals will start growing, and there's dependencies between species and so on. But it didn't require for you to kind of create urban tiles. If you wanted to create urban tiles, by all means, just engage with those. But the game didn't make a distinction between nature and artifice, right? It understood that tiles, both natural and artificial, had or could incorporate this kind of ecological interdependence model. As you can see here, people start populating the neighborhood or animals. Depending on what you create, this kind of happens automatically. You basically creating environments for inhabitants to emerge, right? So that's not controlled by you. It's not that you can just populate these areas, but rather if you hit certain patterns, we can dictate that there's going to be particular cycles fulfilled, right? So like an office worker would emerge if there's a home, and there's a job, and there's kind of a particular criteria for that to happen. And like that, you would be discovering and achieving the unlock of many different urban citizens. And again, those would be both human and non-human. So this is what the game was trying to do, was trying to create a network of interdependence where you can actually understand energy relations between different entities, housing, labor. Some of the currencies that were being transferred between these different entities were very material, like water or actual money, but some of them were more immaterial, like community points or social capital, right? And some of the big challenges that we had is what is the exchange rate between calories and social capital, for instance? So we really work with a community of players that start engaging with the project to find a balance and understand that there is through kind of a long chain of conversions, if you want, you could actually start establishing rate of exchange between these different currencies. So other kind of things based on forms of cellular automata, like the game was definitely using neighborhood relations to establish positive and poisonous synergies. And when I talked about the idea of entropy, is that the game was actually trying to simulate a form of decay. At all times, the neighborhood would be dying, right? Like if you don't provide the water for a tree, the tree would slowly decay to the point in which it will die. But that process would actually happen to all tiles, because all tiles require some form of input, right? So an apartment would decay and get abandoned. Trees and grass would actually dry up, and crops would actually die as well. So you were kind of in charge of maintaining the system to work as a beating heart. You would be in charge of maintaining the pulsation and the relationship between resources. And when something starts breaking down, you would actually be able to go in there and really fix it or realize what are the kind of the general metrics of your community that actually is keeping it over time in a kind of a form of disbalance, right? And there's many things like dynamic weather systems and forms that would actually shape the player and make it more interesting. So it would become a bit of a challenge for you to do so well. This is the kind of thing that we wanted to be able to simulate. This is kind of a form of industrial food system, so the kind of relations that the different tiles would actually have with one another. And then you start thinking about organic food system, and you think that everybody should eat organic food. Well, there's a series of consequences for that. There's different yields, there's different kind of amount of crops that you would need, and a whole different kind of relation between systems. So the player was, had the tools to model those two different models and decide which one was better because of the consequences that they developed. And as I mentioned, you would be working with this notion of urban currencies. So at any given time, a player would actually be able to see its construction in the natural form, or also kind of go into different data modes and visualize what is actually being produced, what is not being produced, what conflict, or what's being decayed, or what is about to die, or what has structural integrity versus what is actually at the brink of collapse, and so on. So there's different data layers that will allow the player to get more informed of what's really going on. Or access. Access was one of the properties that needed to happen, because before access was implemented, people would actually build silos. Like people play, like in a notion of homo economicus, they would actually just play for profit. If the game would give them a way not to relate to reality, they would actually create houses that don't have any corridor or access whatsoever. If that is not penalized in any way by the game, they would actually get away with it. So by the introduction of that, a tile couldn't produce, or it couldn't be able to function unless it had a circulation system, and those circulations have their own kind of challenges and constraints. We really start kind of getting closer and closer to what could be an approximation or a diagram of architecture. What I was very excited about is to see how players would engage this content. This is the kind of spreadsheets that people were sharing in Reddit and sharing in the Steam forums where the game was actually being sold. And this is a kind of a reverse engineering of the data that we're not giving you from the game. So the game provides a lot of kind of synergistic relations between tiles that you need to discover. So when you realize, oh, like an apartment likes having, some park outside, that gives you extra production, or like a small coefficient that was mapped out by the player. So you can see that there's like 4 or 5 tabs in this document showing all the kind of content that people figured out and share with one another so that they could actually learn faster. So this is kind of what people have argued, that games really allow for like collective intelligence, where people create their own mechanisms to kind of share content and grow and play those games faster and better, more efficiently, and eventually modding them to actually change them into something that they're more catering their needs. So some final images of the project. My thesis behind this project was that there's no such thing as an optimum. I hate the idea of optimization, and a lot of computation in architecture has to do with that. But as the famous architect John Fraser mentioned, there's always kind of criteria that are opposing each other, right? He gives the example always of this: if you're designing a boat, you can make it go faster, you can make a lot of people be comfortable inside, but those two criteria are never align with one another, right? So there's a decision-making process by which one pattern will become meaningful for a particular community, or another pattern will become meaningful or valuable for another one. And the player is put in that position at all times. The city is not like a universal optimization engine, but rather one that's actually built by its citizens. So the whole notion here is that how do you create and propagate the patterns for the city? So that's it. Thank you guys.
I don't know how exactly to word this, but would you consider yourself like an architect that got into game development, or would you call yourself a game developer or designer that works with architecture? Like, how would you?
Well, I was trained as an architect originally. If you want to ask me what I did first, I probably did games first when I was a kid. And then I went to study architecture. But my undergrad degree was an architecture degree. And I didn't learn any programming whatsoever in that degree. It was a very kind of hand-drawn, eventually got a bit digital with things like 3D Max and Form Z and things like that. But I studied in Chile, where originally, and it was a 6-year degree, like a very modernist tradition, very much about doing buildings, right? It wasn't until I actually went to London later on where I wanted to learn how to program. So I would say I'm an architect. I have a teacher license in Chile, and I went into gaming. I think I went through generative design. That's kind of like the story that I was trying to tell at the beginning, that architecture has a lot of generative design these days, or for a period of time it became like a really kind of hot topic in architecture. Think of generative work, and now it's become parametrics in some degree of technology to kind of to design buildings by code or by kind of parametric definitions and so on. And I went through that kind of work, and I felt like I was teaching that for some time. And gaming was for me a pivot point pivoting towards mixing some of the intuitive aspects of design that you might have in a traditional architecture practice with technologies that would give you this kind of constraint or kind of like informational environment that I call infrastructure, right? So the moment you build this software, suddenly you can practice architecture, but there's a lot more information running around that could help you take decisions and see the world differently. So definitely would call myself an architect first, and a game designer second. But my passion is in that combination. Like I wouldn't like to leave any of those because I feel like I'm not the most traditional architect and I'm not the best game designer in any way. I find a niche that is interesting between those two disciplines, and they require the expertise of both areas.
Oh yes. Just out of like curiosity, how far off do you think PolyOptics is from like being done?
I don't know. I wish I could answer that question. So it's Blockwood took like 3 years to be developed, but out of that, maybe the first 2 was just me working on my own, right? Like only last year we ramped up. We did an early access, so the game started selling. We used that money to start kind of pumping. I hired a few people that helped me out with animations and a bunch of stuff. So the last year was faster production. So this new project, we're in the same stage. We've done like 1.5 years, I think, of slow burn. We're a very small team. We're 3 people right now. And when we're ready, we're going to ramp into production, which is get all the right animations, making sure that the whole thing looks nice, and there's going to be a story to it. Package it into a way in which it would actually be publishable. Like I'm working with publishers, different kind of gaming publishers that would allow us to take that game into kind of as large of an audience as possible. Why? Because I really feel like if there's money behind the project, I can address issues of sophisticated ecological relations and simulations that I cannot do as a kind of a small team, right? So I don't have the resources to do kind of, I don't know, all sorts of analysis that I would like to do and offer those to the player. And I feel like I am hopefully ramping up these projects towards more complexity over time. And they're kind of stepping stones towards something kind of larger, right? Where you would have like a complete social platform. My idea would be to create a social platform, but one in which people would own their content and we would become a marketplace. So something like what SketchUp is doing, but in a gaming environment, people would actually be able to design architecture, even by regulation, and offer those solutions, sell them, or create Creative Commons content as well. Take the decision. A platform should be able to allow the players to take the decisions that they want. Some of them will be open source, some of them would actually be proprietary, and they would actually be paid for their labor, right? That's up to them to decide. And I think that engaging issues of what are the ethics behind platforms, I think it's kind of particularly interesting to me, especially with the issues of security and what's happening with Facebook and so on. It's exciting to be part of that conversation by designing a small incipient platform, right? And you see the problems, right? Like, do I own the data? Do I harvest the data for the players? Do I use them for my own growth of the company? Or does the data become encrypted and belonging, like, in a way? Am I blind to that content the player starts producing something? What happens with the database? If the content is hosted in a server, what is my responsibility to for the security of the player's content? And it's not personal data, perhaps, but still, I think that when it's the work of people, it really belongs to them. It's important to think of these questions, right? I don't have the answers yet, but I'm kind of trying to write and kind of really offer at the time of release a solution, or a proposition, one that is hopefully different to the one that we see today.
So what's the difference between Code and Blockwood in terms of the technology?
So both games use a very similar kind of ecological diagram, right? I really like the writings of Timothy Morton, And he, if you like YouTube, you can see his very cryptic video of the mesh. And he would describe what he calls the theorem of interdependence, right? And it suggests that things are codependent. Everything should be codependent to one another. And in Blockwood, that was very literal, because everything, let's say, you wouldn't get a tree without the water, but you wouldn't get the oxygen without the tree, and everything was a circle. In commonhood, that's taking not to the scale of the whole factory and the whole building, but it's a much more a much more granular scale. So it's using the same principles. Like you cannot think of this architecture of this building without thinking of the materials and the labor that goes into that building, and then what are the labor practices for that worker. At the same time, there's a whole series of there's a kind of stretch of ramifications from everything that you're doing. And some people might say, hey, that's an overkill. Like, we don't want to have a software that you think like that. That's why I'm doing it like a game, because it might not work for the kind of the scope that a particular practice of architecture might want to have, where they kind of have these silos of disciplines that you're thinking, hey, this is how far you should think in architecture, because someone else will take care of that. That's kind of human research. That's something that if you can get away with it, maybe you do it. But that doesn't mean that you can think of architecture differently. And I think that software often gives you that window. It gives you that frame of view. And I want to kind of shuffle and play around with that. So just to give you a different perspective and think, hey, what would you design if you had to take care of this problem? I don't know what will happen. I think that's kind of what I'm really excited about, because I've seen what people will create in it.
So are you considering those games as noise instead of patterns?
Yeah, that's an interesting way of framing it. I would definitely, my experience is from Blockwood, from Bloom, to Blockwood to potentially Commonhood, is that maybe 90% of the content that people will create out of a social, crowdsourced, open-ended system will be noise. Maybe more, right? But the ones that are not are worth the whole amount of labor that was put into them, right? So it's difficult to arrive to configurations and patterns that have effective meaning and cultural value, I would say, just because of the scarcity of them. Otherwise, you see a lot of really great content out there. But the truth of the matter is that a lot of people try and they end up, as you say, noise with content that is it's like you get a bunch of Legos and you end up building something like a little mutant, But there's some people that actually can do amazing things with it, right? For the most part, I believe that the more actors that there is in a platform, in a field, in a medium, would actually increase the quantity and the quality of the content. So if you have a field of architecture that is very narrow, and it's only allowing a few people to work within it, you're gonna have to kind of be conformed to whatever they can create. But if you start opening that boundary, you will definitely get more innovation, I would say. And not only innovation, you would have, I want to distinguish between what is innovation as a form of progress, as achieving something that is, let's say, an advancement, but a form of innovation from diversity. So perhaps solutions to problems that were not being addressed by this small elite, right? So you might have a whole new niche of people that are engaging, let's say, with, let's say, more social architecture, content that I think that could need more awareness, right? And hopefully that happens when you kind of have a much larger pool of people interested in the medium.
Do you think that architecture can exist in purely in virtual reality? For example, I feel like both your project kind of try to tie it to the world we live in so much. It's to a point like a simulator. But like you're saying that the house needs circulation to move in between. But in fact, in the game, you really don't need it. You can teleport from one place to the other place. So and then people doesn't need to occupy just the floor. Maybe you can walk on the wall or something like that. If the project at a point becomes something like that, kind of breaking the rules in the real world, would you still consider that has some kind of architectural value in it? or is it just like
I mean, a lot of people, if you Google examples of games that have great architecture, right, you will find out that people in popular media would actually praise video games that have somehow, that, like you say, you can walk on walls, or they distort your notion of architecture. Like games like Manifold Garden comes to mind, or a bunch of others that somehow they seem to suggest a form of radical architecture for someone that is a gamer. I'm very not interested in that field, right? Because first of all, they are not architects, so they don't know what is the kind of the legacy of radical architecture. And yeah, that they could definitely distort your perception of architecture. But that's a game environment that it could be very appealing, very alluring, right? It could be engaging in many ways, but it definitely kind of serves a different purpose. I think that it would have to be brought somehow into a relation with architecture that I haven't seen done yet, to start kind of having a kind of a discourse there. But I think that I think that too many people have done it as well. Like there's so much content that engages with the lack of reality of virtual space, right? And you could say, well, why do we have to engage with reality in virtual space? I find that kind of like a beautiful opportunity to really be able to create things. Like you have infinite land inside digital space to craft and create content, with your own hands. That it's otherwise you would need like materials and resources and space and rules and so on. So and creating these simulations that can echo what is really happening and make you think about how you take practice on the real world. That's perhaps my own personal take. But in the case of augmented reality, I feel like that's going to start being blurred quite quickly, and I think it's already happening, right? Because suddenly there is no distinction between the virtual and the real. They're part of the same thing, and then so one of the questions that I always ask is, well, I think we're living through the last years of clients that would actually buy for constructing real architecture, because the day that you can actually make the fanciest facade that you can imagine digitally, it can move, it can change, it can do all the things that you want, and everybody could just tune to the channel and see that kind of augmented reality architecture. Like, who's going to want to print plastic to kind of stamp on front of a facade? I think that there's forms of architecture that we're seeing today that are going to quickly decay, or they're going to become more and more rare, just because there's going to be so much proliferation of augmented reality content once we have the right devices and so on. But I think that that's happening pretty quickly from what I've seen. And I think that some people in this lecture series will explore those areas as well. So I'm definitely excited and scared for what augmented reality will bring to architecture. I think some of your issues will definitely kind of be played out in there in some degree. But I still think that this particular form of research that I'm conducting has a lot of room to grow, because the relation with reality is something that it's giving us a lot of new perspectives still.
I must say it was amazing to see the work. Very exciting. I think everyone's trying to solve this problem, the gap, especially between simulation and constructability of things. And maybe this might be a game, but it might be doing that in some ways, taking this one step closer. There's a sense of a kind of didactic nature to the games, of like teaching something, trying to send a message. Have you thought about using this as an application for education, as far as allowing someone, a young person who's not allowed on a construction site, to really understand the processes of building something? Is that something that you've been considering down the road?
Well, maybe what I forgot to mention in this kind of genealogy, going through the different projects, is that when I started teaching, the first thing I started doing, and it's what probably maybe some of you have checked in my website, is video tutorials, right? I had a commitment to not only learn, but I also kind of share that knowledge with the open source community. I was learning from open source content, and I thought, well, I'm not a good coder yet, but maybe I can teach in a way that it actually is presenting the ideas in a way in which I haven't seen before. And I started doing these video tutorials for quite some time, and I wish I had the time to keep on doing them because they were very close to my heart. And that teaching project was why I got into academia, right? Why I got into teaching. And I thought, well, this is definitely kind of a first level of opening up the knowledge of architecture or specifics of architecture to a new audience. The second attempt to do that was when I did the processing library. I was writing processing code, and I thought, okay, I have a bunch of objects, let's say, swarming behaviors and things that I wanted to share. Many of the work that was influenced by Craig Reynolds and Casey Rias and a bunch of other people. So I could kind of have compiled a library, and I thought, well, open source, I'm going to share my own library. And I was very disappointed. I got like maybe, I don't know, 100 downloads, you know, like, and I thought this is the next way of like sharing content and sharing knowledge, you know, in a kind of free, distributed way. And that wasn't it. So I definitely think that games was the third attempt, and especially Blockhood. Blockhood kind of brought it down to the kind of basics, meaning like it was not meant for a kind of a expert audience. You see the game, and it's meant for a kid, right? It's meant for, like, I mean, a kid that would slowly realize, oh, this is actually hard math. But because the game has this kind of presentation that is didactic, but it's really trying to kind of bring you into some of the complexity. Then you realize, oh, this is actually pretty hard work. Otherwise, everything dies, right? And it definitely got a different audience. It got to, for me, the numbers were important not because of necessarily the funding and the support that we were getting, but just because they were actually saying this medium resonates with a larger public. And like, if you want to engage the production of literacy of what we do and the valuing of architecture, like, you cannot just speak loudly in the echo chambers that we currently have, let's say in the magazines and forums that we architects only architects read, right? But really kind of starting and opening up to a different audience. And I think that that's what games became like, yes, this is my form of engaging with a new form of education, especially because games, different from traditional software, would really, all of them, take the responsibility of teaching you from zero to hero, right? Like you get into the game, you don't know nothing, right? And it will show you what are the shortcuts, they will show you what are the controls, and it will show you slowly the progression to get to a really advanced player. And then players will actually take it from there. Other players will kill you and show you, like, if you don't do this, you're going to still be a newbie in this game, right? So there's kind of a lot of lateral learning. And I think that's what games are doing really great. Like, I think that, yeah, the education aspect of it, people like Sid Meier, the creator of SimCity, talks about stealth education. So I agree with that. I think that there's kind of an informal way of education that is implicit in the game. We have tried to take it to classrooms and do workshops with it, but having 12 people playing the game in a class like this with like computers, it's less of an impact that I'm having like translating the game to a new language and having like 10,000 people playing it in a region and getting forums of people engaging with it. So I think that's what I'm kind of excited to hopefully keep supporting, that the game has a life on its own, and then if we keep supporting the games, those games could actually become educational platforms on their own. Like, people have asked me to do that. Like, I'm happy to give licenses for free for education, for instance, and there's been a handful of workshops done in different places. But I'm trying to keep on the development side too, and yeah, maybe I should be more open about facilitating those educational instances. But definitely, that's kind of an interest of what I'm doing, the relation with the education stuff.
Is there any players in the game who suffer differently and something else that's that makes you think architecture different?
Well, I think that that's my dream of like what this research should achieve. Nobody has sent me a design that is like brilliant, right? Like, meaning like, oh, I didn't know you could do this. People have done like weird things. So someone did like a planet and it was floating. He kind of exploited a bug that would allow him to do like floating content. Or people definitely explore the content in a week. They will explore everything that you developed for 3 years. So it's kind of overwhelming, right? And that's what I find exciting. It's like there's so much power of permutation search, right, in a social structure or approaching a video game, that you really need to think of a game that is very, very open-ended to kind of keep players interested, and content, I mean, games that do it really well, like you probably play Fortnite or things like that, they put players against other players, so the multiplicity of interactions is so large that you could have players playing forever, right? And there's always something new, there's a new kind of moment that you can encounter. Games that work with physics do that really well. The idea of a sandbox is always the idea of an open-ended kind of way of solving a problem. So my general area of research is how to achieve that. If I knew how to do it better, I would probably have a much more successful company. But I hopefully in the next few years we're going to start seeing good, great architecture, and hopefully people like taking these ideas into the real world, fabricating things. We're actually trying to do small prototypes and content, fabricating some of the things that you can do in Common Hood to demonstrate that this is a game that is trying to reach the real world with the gaming world. But I'm hoping that maybe the maker movement or the tiny house community or someone will actually start kind of using these platforms to design their content as well. That's kind of all that.
So, here in our applied computer science program, we use computer science we apply computer science to different creative disciplines, right? And I think your work is a great example because you don't only apply to one, you actually bridge two disciplines together, which is gaming and architecture. And I was wondering if you could speak a little bit more about your role within projects. And you spoke a little bit when we were talking to Harry, you said that at the beginning of one of the projects you were mainly the main developer. Mm-hmm. And I was wondering if you could, for example, the last project, when obviously the scale is growing, what is your actual role? Are you still a developer or not? Or are you beginning to distance yourself from that part? And how do you see your role in the future?
Yeah, I always say I have a good day when I wake up in the morning and I get to code all day. You know, that doesn't happen too much lately though, because I mean there's some academic kind of relations that I have, and things that I have to be addressing. But like since the program, the first processing projects, the kind of the work that I was having in practice was always kind of writing code and setting up these simulations. But always with, I think, I would say, an artistic direction or a designer direction, because I wasn't an engineer. I wasn't doing things in the most optimal way anyway, right? I was definitely someone that had like a very particular design vision of what I wanted to happen. So many times projects wouldn't be packaged or it wouldn't be documented, or by all means you don't want to see that code at all. Like, it was terrible. But it was getting done what the design objective was, right? For Blockhood was the first project where I kind of told myself, it's like, okay, this wants to be a professional project, one that you will actually sell, right? So there's a different kind of commitment with an audience, and there's a different kind of support, and there's a different kind of approach to a project that would take many years. So it's kind of, I felt like it was like writing a book in a way. But everything was this kind of big programming project. And as I said, for 2 years I was working alone, and then I kind of started hiring. But nobody touched the code. I couldn't at that point bring people in that would touch the code, because it was a mess. It was like, it still is. It's just like, it's kind of like a big, it's kind of in a way you present what is in your mind. But I was able to kind of create enough interfaces. In Unity, for instance, you do editor scripting. You can allow for panels and content to be input by others. So all the members of the team had access to the databases. Everything was a database. Like the blocks were a database, the animals and the humans, the inhabitants, the resources. So if you were doing animations, 3D modeling, or textures, or icons, or whatever, they would have panels for each one of them that they would just be inputting the material, and I was managing the code. Eventually, we did the VR version of Blockhood, which was externalized to a company. So we worked with another company, we gave the guidelines, we created a prototype, like it worked perfectly in VR, we were really happy with it, and it's like, this is what we want. And they just make sure that it ran really well. So that was kind of a partnership that we did there. And with Common Hood, I started writing some of the first prototype of the game. one of the persons that is working with me is an engineer, so he has taken kind of a lot of responsibility on the code. And yeah, that's some of the challenges right now, is to kind of keep track of everything that is going on. Like I'm not the main developer. I develop portions and sections of the game. And sometimes I have to work on geometry as well, or like finding the atmosphere. So I'm definitely more of an artistic director of the project, but someone that really knows everything that's going on. So, but in a project of 3 people, you cannot be so far from what's going on either. So there's a main developer right now, but the 3 of us definitely code and engage with the programming of the project. But I would like to continue in kind of a very, very hands-on extent with the development of the project. I don't like so much of the business side of it. I think that these projects need a lot of attention to get to a point in which they actually could be played by others, and that's something that I don't feel comfortable yet to completely say, hey, just make it happen and I'll do the business side. I think that you need to kind of keep, the craftsmanship, I think it's kind of the main argument that I always kind of, even digitally, you talk about craftsmanship, you have to kind of be close to what you're doing. And some things you kind of think of unless you're doing them. I was always against some people, like some of my mentors were always talking about computation without ever writing code, right? And I was like, well, how can you even conceive of computational ideas if you're not kind of crafting them, if you're not kind of coding the relationships and the principles? And that's what I got when I was writing code. So I apply that same principle to myself. It's like, if you're too far from code, you're not going to really get how to create this kind of simulation. So I need to kind of understand systems from the inside. So yeah, that's the challenge, I guess.
Lots of questions. Thank you so much.
No problem.
Amazing.